Hello everyone, my name is Ellen Bergseth. I'm from the ITM school at KTH. I work at the machine design department, and our research supports decisions made during the early phases of product development, decisions that are important for the whole product lifecycle. I have titled this presentation Condition Monitoring, since that has been my main focus for the last years. Motivation. Everything I do in my research is done to ensure that the required function and the desired product performance is achieved. And I believe in finding the best system, not only the best components, even though my research is mainly on a component level, studying physical phenomena linked to certain failure modes. I always strive to be able to diagnose these failures when the product is in service, whether a failure has or will occur. The components that I study are heavy wearing and loaded components that can, for example, be found in gearboxes in a wind turbine. And the way I do research is model-driven, which means that I make models so that later on estimations can be made based on real running conditions. I will now give you one example. This is not a wind turbine, but it's another heavy loaded contact, the contact between the wheel and rail. And in this project named Quiet Track, the purpose was to make railway maintenance more efficient. And our hypothesis was whether we could use sound measurement to detect normal wear going to severe wear in the railway contact, to be able to detect when we need to lubricate the rail, for example. So this model-driven approach, first, the step is to create a model. And in my field, tribology, we mainly do lots of experimental testing, but we also do simulations. But first, create a model, basically. And model tests are cheap, are less, means less cost and more system control, but man really have to make sure to imitate the same failure modes, the same wear mechanism. And studying the wear mechanism in the real world and in lab, comparing these is one way of securing that you have the same failure modes. And in this case, we could see that sound amplitude, pressure amplitudes and sound pressure levels, the transition, we could see synchronously with the transition from normal wear to severe wear, we could see these changes in sound pressure amplitude and sound pressure level. And so we set some criteria according to this. And then we verified this model in full-scale test in a depot and tuning this model. And later on, this model could also be validated in field. It is now installed since 2018 on 7 trains in the Stockholm Metro and also in Malmbanan. This measurement system now samples a huge amount of data, and this model-driven approach can also act as a base for data-driven approach with supervised machine learning. But that's another research story, so to say. Thank you for listening.